So we'll talk about like what is IBS. So we have already discussed this in our session 1, but in this session we'll just give a high recap, and then we'll go through repeaters. What are the different vendors for repeaters, different vendors for small cells, different vendors for splitters, couplers, triplexers, diplexers, attenuators, antenna, etc. And also for active, passive, and hybrid DAS. I have used various reference sources like 3GPP, YouTube videos, YouTube screenshots, IBWay videos, Scribe, and one of the best site is Course Hero to get the all documents related to telecom, award solution, fierce wireless, and OEM original website, or an align parallel wireless. All these reference sources I have used to make this paper. So it's important that a radio designer knows the basic of all various types of indoor coverage distribution solutions. In many projects, the best solution will be the combination of all these solutions. So good indoor radio planning needs a well-equipped toolbox. So having only a hammer might solve many problems, but only having a hammer in your toolkit will limit your possibility. If you know what is passive DAS, what is active DAS, what is leaky cables, repeaters, then you can better perform your indoor design. Right? So indoor radio planning is not about using one approach only. Learn the pros and cons of all the various kinds of indoor tools, and then you can become a better IBWave or in-building design engineer. Because often the best approach will be the combination of different solution types. Hi friends, it is so good to see you all again. This is Gaurav Goyal. First of all, thanks a lot for joining this training. I really appreciate from core of my heart for giving me your precious time. I will try my best to make every second of your work through this session. And again, this is me. My name is Gaurav Goyal, and I have been in telecom industry for over 18 years, mostly in the wireless industry. I have worked for all the largest telecom service providers in US like AT&T, Verizon, T-Mobile, etc., and also with major vendors like Nokia, Ericsson, Huawei, etc., and mostly in the in-building DAS. And in addition to DAS, I work with Infovista as a product manager for their Planet tool. And before coming to US, I worked in various projects for various countries like India, Nigeria, Japan, Finland, and UK, etc. So much of that time has been spent in wireless networks only. I have begun my career with 2G and now working with 5G for at least last 4 years. And at this moment, my focus is on 5G, Python, ORAN, and in-building solutions. And I'm IBWave Level 3 certified, which is the highest certification for in-building engineers. Okay, friends, so this is about me. And for more details about me, you can check my LinkedIn profile. And these are my ID cards from previous companies. And you must have seen this picture lots of time in the past. So I have always tried to understand why some people are able to break through barriers and grow, while others get stuck in the comfort zone. The simple answer is this: fear zone. So fear is the only thing holding us back. Fear hold us back from experience more joy and happiness. Fear stop us from leaving the comfort zone, but also prevent us from moving into the learning zone. It is like a wall that blocks us. You can see this black wall. So this is like a wall that blocks us. So when we try to overcome fear, often we just ignore it or push it down. However, the fear we ignore eventually limits our ability to move forward. So most of us actually avoid fear at any cost. I have learned if you want to grow, we have to face and move through fear rather than pretend it is not there. So what does it mean, moving through? So well, rather than trying to make fear go away, we move through it and make the fear conscious. Okay, so fear should be conscious. So when we make fear conscious, the fear no longer has power over us. And once it has no power over us, we slowly gain control over it. And once we move through fear, we can learn new skills in order to grow. And now there will be no barrier of fear standing in our way. Although this is not an easy task, it is well worth the effort. So it's our duty to always move towards growth zone. And how to achieve the growth zone? Growth zone can be achieved only by growth mindset. And what is the growth mindset? So always say that mistakes help me learn. I improve with practice. Feedback is valuable. Is this my best work? If it is not my best work, I will try my best next time. I won't give up till I achieve my goals or my dreams, right? And how to achieve growth mindset? Growth mindset can be achieved only when you invest in yourself. So never lose your childlike curiosity. Be a lifelong learner by reading good books, taking online courses, learning from mentors, experience new things, because the highest rate of interest comes from investing in yourself. So a few years back, I made a goal that I invest this amount of money every month on online courses or buying some books or something else, right? So you should also invest in yourself by reading books and taking online course. Remember, my friends, if you try to achieve something, there is no guarantee that you will achieve that. But I will give you one guarantee. If you do not try, you will never achieve it. So keep on trying with your full potential and complete honesty, and leave the results to higher powers. I think enough of motivation talk. Let's move to the topic. So before jumping to topic, I want to say one thing. Your involvement in the class is critical for you to benefit most from this webinar. So I request you, if it is not absolute necessity, then please close your Outlook, social media, Facebook, WhatsApp, etc. if possible. Because it's a proven fact that there is no such thing in the world called multitask. Even a genius can't do two tasks at the same time. So it's my kind appeal to everybody, please close all kind of social media or any kind of distraction. So I will offer lots of bonuses and offers on my complete 5G course. So please stay till the end. So are you with me? So if you are with me, please write yes in the chat box, and then we'll move to our training. These are the few acronyms. So let's jump to IBS, in building solution. So what is IBS? So IBS is the cellular service inside the building to provide better coverage, capacity, and quality. And how it does? It does with the help of this called DAS, distributed antenna system, with the help of which we can evenly distribute signals in the all target area. So why is in building important? So according to a survey, 80% of calls and data sessions are initiated indoors. Let's take one example. Let's divide normal 24 hours. So just imagine from 12 to 6 a.m. Okay, 7 hours. So probably you are sleeping or preparing yourself to work. Okay, so that is 7 hours. That is equivalent to 29% in a day's life. Okay, then 7 to 8, maybe 1 hour commute, that is 4%. Then 8 to 17 or 8 to 5 p.m. we will remain indoor, that is 42%. And after 17 to maybe 19, 2 hours again commute, so again outdoor. And then from 19 to 11 p.m. we are indoors, right? So if you see the typical life of a professional, just 12%, 4% here and 8% here. So just 12% are spent outdoors. That's why we need in building solution. And again, if you take one more example, you can see here, if you have line of sight to the cell site, you will have good outdoor coverage, right? You have good outdoor coverage. But if you go indoor, now that is the start of bad indoor coverage, right? That's why in building solution is very important. Again, why IBS? As you know that modern environments such as commercial buildings and sports venues often require excellent coverage and capacity. But we have various kinds of barriers inside the building. Like you may have various kinds of walls. It can be steel walls, it can be concrete walls, it can be wood walls or wooden walls, it can be glass walls, and it can be furniture inside the building, right? So these walls and glasses can easily prevent cellular signals from reaching the mobile devices of the people inside. So these walls and furniture inside acts like a RF shield. So one reason why we require IBS, because these walls act as an RF shield, right? So one reason is RF shield. Second one is high-rise structures. So high-rise structure may also experience high RF interference from nearby cellular towers. So this can further degrade service. And third reason can be overcapacity, right? So overcapacity with too many people occupying a small space is third cause of poor mobile device reception. So these factors combine to cause poor cellular device reception. So DAS is required to overcome all these three issues: RF shield, high-rise structures, and the overcapacity issue. So an integrated DAS solution is essential to enable quality cellular service and accelerating the future growth of wireless network. So a DAS is an in-building wireless enhancement system that provides building occupants with reliable cellular device coverage and capacity. So a DAS is a network of spatial separated antenna nodes that expands the cellular range and boosts signal strength. The DAS helps to achieve superior cellular connectivity in a high density indoor or outdoor venue. So once the radio signal is inside the building, it must be distributed across the building. So a DAS splits the transmitted power among several antennas so that our reliability can be improved. This is possible because less power is wasted in overcoming penetration and the shadowing losses. So what is shadowing? So shadowing basically refers to loss in signal power due to obstructions in the path of propagation. And there are various ways to overcome shadowing, but the most effective way is the line of sight propagation. So with the help of DAS, we have more chances of line of sight and we can avoid shadowing in case of DAS, right? And one more thing, as you know that free space path loss, right? Free space path loss is equal to 32.4 plus 20 log D plus 20 log F, right? So suppose distance between antenna and user is 100 meters, right? Let's suppose 100 meters is the distance and we are using suppose 2.4 gigahertz, right? Then what will be our free space path loss? It will be 32.4 plus 20 log D. D is in kilometers, so it will be 0.1 plus 20 log F, right? So F is in hertz, so it will be 2400. So value will be around 80 decibels, right? But if we increase the distance to 200 meters, just 100 meter distance, if we increase, then what will be value? 32.4 plus 20 log 0.2 plus 20 log 2400. So it will be 86 dB. So just by increasing the distance of 100 meters or just doubling the distance, our free space path loss increased by 6 dB, right? So with the help of DAS, we can increase our free space path loss as well, right? That's why DAS is very important. So let's talk about the work of an IBS engineer. What kind of work we do as an RBS engineer? So RBS engineer has to do various kind of activities, like we have to add source to neutral host, we have to add new carriers, right? New carriers to existing sectors. Then we have to add or split sector on existing DAS. Then we have to rip and replace DAS upgrade, right? Also we have to do we have to add areas, floor and antennas to existing sector. So these are the basic activities we do as an RBS engineer when we are new or when we have experience of few years. But in addition to in-building design and planning, we have to manage multiple projects and provide regular status update to management as well. And we have to compile and maintain all the project documentation. Also, we have to do work related to like plumbing diagram, RFDS, CIQ, E911, IB wave design template, etc. Right? So we have to perform cost justification studies for ordering and deploying network components. So apart from this, we have to coordinate with building owners and construction team to get the workable solution. So we have to interact with lots of people and understand their needs and provide efficient and workable solution. So in addition to RF design, we have to perform lots of other activities as well. So if you want to become a DAS engineer, then get ready for lots of hard work, right? So in-building tool. So right now, best in-building tool for in-building design is IBwave. So IBwave is the global provider for innovative in-building wireless software solutions. And the motive is to help better design and plan multi-technology wireless network inside buildings and other kinds of venues. And IBwave is a global leader at innovating and delivering software solutions. And it keeps the world connected with simpler and faster designs for in-building wireless networks. The great point is that these designs are quite affordable, right? And these are the main products IBwave offers, like IBwave Design, IBwave Unity, IBwave Mobile, and IBwave Wi-Fi. And in addition to that, they provide certification also. They have various certification, but the main certification are like IBwave level 1, 2, and 3. And these certifications are the best certification available for in-building engineers. So if you want to become a great in-building engineers, I highly recommend that do these certifications from IBwave. And these are the modules offered by IBwave, like propagation module, optimization module, and the collection module. In short, This is the best tool for in-building design. I'm using it for many years, and it makes my work so much efficient and productive. And before jumping to our in-building design, so we should learn some basic RF terms and units. So first one is frequency. So as you know that frequency is the number of occurrence in a given amount of time, and frequency is 1 divided by time, and the units of frequency is hertz, and it is cycles per second. So number of cycles in 1 second, right? So this you should remember, and it is named in the honor of Heinrich Hertz. And these are also terms we will use often in our training. So we should know that what is peta, what is tera, what is giga, and what is milli, micro, nano. So these terms we should know, right? So trillion, billion, all these terms are very important and you should know. So then we have this logarithm scales. So why we need this log scale? Suppose we have to compare two power 1 and power. Suppose power 1 is like 1 million times. So power 1 is 1 million times greater than power. So it's not easy to write such a big number, right? So instead of that, we can use log scales, right? So you can compare. So 10 divided by 1, and if you take log, it will become as 60, right? 60 is easy to write, but 1 million is not that easy to write, right? So that's why we need log scale. Let me give me one more example. So logarithm scaling is useful for comparison over a very large range, right? Because 1 million is not easy to write as compared to 60, right? That's why we need log scale. So how log scales work? So in the linear, it will be like plus, right? 0 to 10, then 10 to 20, it will be plus 10, plus 10. And if you go to left side, it will be minus 10, minus 10. Then we get minus 10, minus 20. But in case of log, in case of addition, it is a multiplication in case of log. And in case of subtraction, and in case of logs, it will be subtraction is converted into division, right? So how? So with the help of this log, we can shorten the term. And for that, we have term called decibel. Why it is called decibel? First of all, it is invented by Bell, and deci means 10, right? That's why it's called decibel, right? So Bell Telephone Laboratories was trying to quantify the signal loss in telegraph and the telephone circuits. They defined 1 bell as a ratio of 10x. So 10 bell is 10 decibels, right? 10 decibels. So let's talk about some common log values to remember. So you should know that when you divide 1 by 1, the value will be 0 decibel. Okay. So 1 by 1 is 0 decibel. But when we increase the number by twice, 2 is to 1, then it should be 3 decibel. So this is a number you should remember always. By doubling the number, it will be 3 decibel. And if you halfen the number, then it will be minus 3, right? These two numbers are very important to remember, 3 dB and minus 3 dB. So ratio of half, then it will be minus 3 dB. Ratio of double, then it will be 3 dB. These two numbers are very important to remember, right? So after that, it will be same like if you double 3 dB, so it will be 4 times, then it will be 6 dB, right? And it 10 times, then it will be 10 dB. 100 times, it will be 20 dB. Okay. So can you please answer this question? So what is the factor of 250x? Please write answer in the chat box. Thanks all for giving the right answer. It means you are very attentive. Thanks for paying all the attention. So as you know that 100 is 20 dB, right? So if you add 3 dB to 20 plus 3 dB, then power will be double, right? Then it will be 200 here, right? 200. But we are looking for 250. So it will be around 24 dB, right? And there is other way to solve this problem. So if you write like 10 log 1000, right? 1000 divided by 1, it will be 30 dB, right? And if you write, if we half the 1000, then it will be 27 dB. If you again half to 250x, our question is related to 250x. If we do it 250x, then it will be 24 dB, right? So this way you can find the answer of any factor of any value, right? It may be 250x, it may be 500x, it may be 1000x, right? This way you can calculate it, right? So 250x will be 30 dB minus 6 dB, and our answer is 24 dB. Thanks guys for giving the right answer. You guys are really awesome. And then, so dB or not dB? So since dB is a measure or relative difference, how can we talk about actual absolute power level? We simply define a reference power by custom and use it for P naught. Generally, we use P naught is equal to 1 milliwatt. So 10 log P milliwatt divided by P0, right? So 1 milliwatt. So these are the few items you should remember. So 1 watt is equal to 30 dBm. This is the quantity you should remember. If you remember this, you can calculate anything with the help of this log table. So 30 dBm, 1 watt is equal to 30 dBm because 1000 milliwatt divided by 1 milliwatt and we take log, then it will be 30 dBm. And 10 milliwatt will be 10 dBm and so on. And 2 watt will be 33 dBm. Because as I said that for every 3 dBm increase, power will be doubled, right? Can you let me know the dBm value of 11 milliwatt? And remember my friends, 11 milliwatts can be 10 milliwatt plus 1 milliwatt, but it can't be 10 dBm plus 0 dBm, right? Because 1 milliwatt is 0 dBm and 10 milliwatt is 10 dBm. So you can't add dBm and dBm like this, right? So can you please tell me the value of 11 milliwatt? Thanks guys again for giving the right answer. So right answer will be 10.4 dBm. Can you give me the value of this 110 milliwatt? You guys are really great. Yes. So answer will be 20.4 dBm. Thank you guys. So let's move to the IBS type. I hope dB and dBm are cleared because this will be used many times in next few slides. So this is an important concept of dB versus dBm. So what are the types of IBS? So we have already discussed in our previous session all types of IBS. So just recaps of the name again. So there are various types like repeaters, passive dash, active dash, hybrid dash, small cells, leaky feeders, and so on. So let's move to the first concept of repeater. So when we say repeaters, it is like an coverage amplifier or an coverage extender. So it extends your coverage. So you can see here, there is an existing outdoor site, right? We call it donor site. Then we have, so typical signal from an outdoor site, existing outdoor site, feed the antenna. So we call it donor antenna. And then it will feed into the amplifier. We also call it BDA, bidirectional amplifier. So it will amplify the signal and then you will distribute the signal inside the building. But the source is an existing outdoor site. So what happens here is that there is improvement in the coverage, but the capacity is shared with outdoor site. So no improvement in capacity. So in-building repeaters are active devices used to overcome the path loss between the macro cell networks and the in-building users, because there are high losses produced by walls and other building partitions, furniture, concrete walls, steel walls, high efficient glass walls, these kind of things, right? So idea of providing coverage using a repeater is to use a highly directional antenna called a donor pointing to a serving macro cell site. The downlink signal is amplified in the both directions. That's why it is called bidirectional amplifier. So repeaters are used to extend coverage to weak or unserved areas where dedicated capacity is not required. In other words, the use of repeaters can be seen as a means to distributing available coverage and capacity. So the use of repeaters to provide in-building coverage is very popular since it involves low acquisition and the operational cost. And this technique has also proved to be reliable for extending coverage and also to create an dominant area. So we have some issues with repeater also we should take care of. First of all, we should take care of the bidirectional amplifier, right? We should take care of their noise figure. We should take care of for their gain, their power, etc. Right? So noise floor levels are very important. Then second thing we have to take care of is placement of BD, right? So if you remember, we talked about Fry's laws or Fritz's laws in the last class. So in that case, we have discussed that noise factor is equal to F1 plus F2 minus 1 divided by G1 plus F3 minus 1, G1, G2, and so on. So the BDA is recommended to be placed as close as donor antenna as possible to minimize the overall noise factor. And then we have to take care of capacity issues as well. So a repeater can extend coverage inside a building, but at the expense of stealing capacity from the donor macro cell. Thus, it becomes a very good solution if capacity is not an issue. Let's talk about some of the vendors used for repeaters. The number one vendor is CommScope repeater, right? So let's talk about CommScope repeater. So all this information is available on their website as well. So if you click on this link, you can see all this information is available on their website. And if you click on this link as well, so you get all this information about the repeater system from the CommScope. All these repeaters are also available on their website. So CommScope repeater support up to 4 frequency bands in a single chassis, right? And it is available in both medium and high power class RF. So these are the RF card, like 4 RF card possible. And then we have this combiner, and from combiner signals goes to antenna at high level. I will show you in next few slides the real life example as well. So this is how a repeater works. So you can take one example. Suppose we have two operators, operator A and operator B. So there is antenna. Antenna is fed to lightning protector, and then signal is going to RF cards, right? So here we are using this antenna. This antenna is from CommScope company, and the number is this, and it is 6 dBi flat panel antenna. Means it is an directional antenna, and it supports frequency between 1710 and 2170 and 2170 to 2490 megahertz. And what is the gain? So gain for this particular antenna is 30.90 dBd. What about their beam width? So horizontal beam width is 30 degree and vertical beam width is also 30 degree, right? So these are details you should see while implementing or while choosing any antenna, right? How much is the gain, which frequency it supports, what are the horizontal beam width, what is the vertical beam width. All these parameters you should remember. Also, you should also take care of PIM value. What's the PIM value of this? So in this particular antenna, the PIM value is neg 150 dB. After that, we should take care of the cable as well. So between antenna and between RF card, or between lightning protector and RF card, we are using a coaxial cable. Right now we are using this LDF4 50A cable in this particular project. So you have to remember one thing, that as we move from low frequency to high frequency, our cable losses increase. So you can see here at 500 megahertz, our cable loss is around 1.55 dB per 100 feet. But as we move towards 1000 megahertz, our loss is 2.2 dB per 100 feet. So as we move towards higher frequencies, our cable losses increases. So this you should also take care of it. As I said, this is our lightning protector, and they are using the company called Polyphaser, and this is the code. And then we have this splitter. So we'll talk about splitter in details. So splitter is used to split the power, right? So this is two-way splitter, right? Suppose power is coming 10 dB here, right? So this is a two-way splitter. So we have to reduce power by half. So if you remember, if you reduce power by half, so it means we have to reduce power by 3 dB. So each port will get 7 dB, 7. Right? Then we have this is called system rack or chassis, where we can put our RF card. So this is our chassis. And if you want to get more information related to repeater RF card, so there is a beautiful link here. So you can go here, and if you click here, and you can see the specifications. So all things are available online on their company's website. So if you go to this specification, you get all these specifications, right? So this is the RF card for PCS band, right? And check the gain. So gain is around 94 dB, right? And noise figure is 4 dB, right? So you should take care of noise, gain, and which frequency this particular RF card supports. And output power is 30 dBm. Maximum and minimum is 21 dBm. And same thing, this is the card for AWS band, and gain, then noise figure, then output power. You should take care of it, right? So this is the card for 850 band, and all these parameters are here. And this is the card for, these are the downlink parameters for 850 cards. So here you can see gain is 84 dB, and our noise figure is 4 dB, and all these parameters, right? And then all these signals also require, then all these RF card also require power supply. So here we have this power supply, and all these RF cards, and then combined with the help of combiner. So you can see here a 4-way combiner, right? And after combining, these signals will go to a splitter, right? And from splitter, those signals will go to the antenna, right? Those signals will go to the antennas. You can see here, those signals will go to antennas. Here they are using CellMax antenna, and this is like a omnidirectional antenna. So here you have to see various parameters. So you have to see what's the gain of this antenna, what are the various parameters, what are the various frequency it supports, and you should also take care of PIM value. Like here they are supporting 140 dB, and they are using CellMax antenna, and it is an omnidirectional antenna. So O means omnidirectional, right? So again, there is an donor antenna. Donor antenna is connected to RF card. RF cards are connected to combiner, and combiners are connected to splitters, and from splitter signal will go to the antenna, right? And same with public dash also. Only difference between public dash is that there we are using an Yagi antenna, right? So this is all about CommScope repeaters. And then next important company is Cell-Fi repeaters. Let's talk about Cell-Fi repeaters. All these details are coming from these websites. So if you go to this website, like they explain it very well how to use this, all these things, right? So we'll discuss. You can see all those components are there on their website. So let's talk about Cell-Fi repeaters. So in case of Cell-Fi, they are using various components like NU and CU. NU is the network unit and CU is the coverage unit. So one NU can support 4 donor antenna and one NU can support 6 coverage units, right? You can see here NU and CU, right? So 4 donor antennas can be fed to NU and an NU can support 6 coverage units. So these are the various components. Like I said, one is network unit, then we have this coverage unit, then we have this fiber hub unit. So if distance between repeaters and antennas are large, then in that case we can use fiber hub instead of coverage unit. So if distance to the antenna is large, we can use fiber hub because Cat6 cable can go up to maximum 100 meters. So you can see one example. So we have this donor antenna. So donor antenna is fed to network unit and then network unit is fed to the repeater, right? And after that, they are fed to the antenna. Or network unit can be fed to this fiber unit and then fiber unit can fed to remote unit and then remote unit will convert optical to RF and then we can go to antennas, right? It is not showing here in this figure, but this is how it will work. So as I said that the length of Cat6 cable can be maximum 100 meters. So if you want to extend cable, then there is a thing called Quatra 4000 range extender is also available. So with the help of that, you can increase the range up to 200 meters. And these are the other devices, like as I said, range extender, then you can use high gain directional antennas and then server antennas and all these things, right? So these are the components inside the Quatra 4000 repeater or the components required for Quatra 4000 repeater solution. So you can see first thing is this network unit, right? This is the network unit and it can be used for various frequencies like 700 band, 800 band, B14 band, all these kind of band, it can be used, right? So it can serve Verizon, it can serve Sprint, T-Mobile, all the operators it can serve, right? It has maximum gain of 30 dB and output power is 23 dB. Then we have this fiber unit and as I said, fiber unit is fed to remotes and remotes will convert optical to RF and then we can feed it to the antennas, right? So in case of long distance, we can use fiber repeater hub instead of this repeater, right? Then we have this repeater, which is 4000i model, and it can serve all frequencies and all operators, T-Mobile, Verizon, Sprint, etc., right? Dish, right? So its gain is around 70 dB and noise figure is 5 dB and it has output power of 23 dB, right? So these are the few parameters you should take care of. And the donor antenna they are using here is the Nextivity antenna and it is a directional antenna and parameters you can see here is like their gain is 7.85 dB and with frequency it can support here is written here, right? And we should take care of beam width. So its horizontal beam width is 70 degree and vertical beam width is the 15 degree, right? And we should also take care of cable. So cable length, as I said, maximum can be 100 meter. This is Cat6 cable or you can say twisted cable and it can be maximum 100 meters. And with the help of this Quatra 4000, we can extend the range as well. So suppose power comes out from repeater is like 12.99, right? And then power from repeater is fed to this 3-way splitter, right? So after some fiber loss or cable loss, then it will be 9.67, right? So input at this splitter is 9.67, but it has loss of 4.8 dB. So output will be 4.52, 7.39 and so on because 9.67 and minus 4.80 dB. And after that, it is through this cable losses, it is fed to antennas, right? And antennas has a gain of around 2.66 dBd, right? So input at the gain input at the antenna is 3.25 and output is 5.50. So at high level, you should also understand this kind of link budget. You should have an idea that if I fed this amount of power from repeater, then how much gain or how much output power there will be at the antenna. So you should calculate that in your mind as well at high level, how much power with the help of this calculation, right? If you don't have IB wave, then you should also be able to calculate if I use repeater, splitter, cables, antennas, what can be my approximate output power, right? So you should also understand these kind of things, right? Thanks guys for giving the right answer. So we have seen real world examples of 4 major repeater providers. First one is Node A repeaters from Comscope, right? Then we have discussed Nextivity, Selfie, Quatra, 4000 repeaters, right? The third repeater we have discussed is Comba repeaters. And last we have discussed ADRF, right? So we have discussed in detail node repeaters, selfie repeaters, combo repeaters, and the ADRF repeaters. Thanks a lot for paying so much attention till now. So let's move to the next topic. The next topic will be the small cell. So what is small cell? So small cell is small cell is a mini base station. They're specifically designed to extend the capacity of a cellular network. So these are low power radio access nodes and they can be deployed indoors, outdoors, wherever you want. So they usually have range from 10 meters to few kilometers. Therefore, mobile operators use small cells to extend their service coverage and increase network capacity. And according to a report, right now, over 12 million small cells have been deployed across the globe. And the number is forecasted to go around 70 million small cells, 70 million small cells by 2025. So they are an important element of network densification. So you should have good knowledge of small cells if you want to become a great IBS engineer. So again, why small cells? So very self-explanatory. So depending on the specific needs of the customers, small cells can be used to enhance the coverage and capacity where macro solution may not be possible or may not be fully efficient, right? So they are used to improve low coverage of a signal. If you have zero signal in the basement, then small cell solution can be used. Then capacity can be improved with the help of small cell, and with the help of small cell, we can offload the macro site as well, right? So what are the various types of small cells? So small cells can be femtocell. So femtocell is the smallest type of small cell that covers a radius of around 10 to 100 meters and can be used in home networks. So in what scenario it can be used? So in scenarios where a person has access to high-speed broadband, a femtocell can be installed. The femtocell transforms a high-speed broadband connection into a cellular service, and that can be used to make phone calls and send and receive SMS messages, right? Then we have this picocell. So picocell covers the radius of around 200 meters, and the picocells are usually used at places with high crowd density like festivals, stadiums, concerts, and other large gatherings. And picocells are larger than femtocells, and they can serve 30 to 100 users. And the last one is microcell, and this is one which is mostly used in proper in-building solutions. So microcells are the largest form of small cells. It can cover an area of up to 2 kilometers and they can serve 100 to 2000 users. So small cells are low powered radio access nodes. So they are used in a densely populated urban areas. And what is the aim? So aim is to increase and improve coverage and capacity for the cellular standard. So every small cell is basically a cell on its own, and it is the complete base station plus the antenna in one box, like an access unit in Wi-Fi, right? So it will be base station plus antenna in one box. So this is small cell, and the small cell is connected to what you call Ethernet switches, and Ethernet switches are connected to a controller, and then controller is connected to the core of the network, right? So this is the high level block diagram of a small cell, right? So what are the advantages? So advantages are like they are relatively cheap to deploy, they are quick and simple installations. So disadvantage is that 1 or 2 bands can be supported. So initially, so on some radios, only 1 band can be supported, or dual band small cell is available. And on some radios, or on some small cells we can support 3 bands as well, right? So suppose at one location we have to require suppose 4 bands and you are using dual band small cells, then in that case at least we have to require 2 small cells at that particular location. Like few years back these small cells are for particular operator or for particular carrier, but now they can be used as a neutral host as well. Okay, so these are the few advantages and disadvantages of small cells. So let's take one example or one vendor example of small cell, that is Corning small cell. All details are available on this website, so you can go to Corning OEM website and then you can get all the details. So if we click on this link, all those details will be available. So let's talk about the Corning small cell. So Corning Avron small cell spider cloud enterprise RAN. So if you Corning small cell can be also known by spider cloud enterprise RAN, because I think Corning has bought spider cloud 5-6 years back. So Corning small cell solution is also called spider cloud ERAN solution. So this is the high level diagram of Corning small cell. So you can see that there is a service node. Service node is connected to the aggregate node, and aggregate node is connected to the PoE, and PoE is connected to the radio nodes, right? We'll discuss all these components in detail in next few slides, but this is the high level block diagram. And always remember that between PoE and radio there will be always Cat6 cable, or you can say twisted cable, and maximum length of that cable may be, so what can you please write in the chat box what can be the maximum length? So the maximum length of Cat6 cable can be 100 meters. Okay, so always remember the maximum length between the radio node and the PoE can be 100 meters. So let's talk about front haul and back haul designation. So this green line is the front haul and this red line is the back. So front haul connects radio nodes to the service node. It can be through aggregation switches or PoE plus switches, never directly. And Ethernet cabling is required up to the radio node. And then we have this backhaul. So backhaul connects service node to the core network. So here copper or fiber between service nodes and router can be used. And generally we use IPv6 and it can cover from service node to the carrier core net, right? So we have front haul and the backhaul. Then we have this Corning radio node family. So here you can see that various options are provided by Corning. It can be SCRN 310, 220, 320, 330 and 340. So various kinds of bands are supported. So in case of 310, they support band 4 and 13 and 4 and 2. So this is a dual band small cell, right? And peak speed is very important. So here peak speed is 225 Mbps, and here in 320 the peak speed is 270, and here in 340 peak speed is 150 M. And maximum number of active users supported is 128 per band in case of 310. So maximum active users one small cell can support is 256, right? So you should remember in case of Corning, maximum user one small cell can support is 256 users, right? So one radio is equal to 256 users. Okay. And in addition to that, what's the coverage? So coverage for 310 is around 8,000 square feet. For 228 will be 10,000 square feet, and so on, right? So also we have to take care of coverage as well. So coverage is 8,000 to 10,000 square feet for SCRN 310. For 220, it's between 10,000 to 30,000. For 320, between 10,000 to 13,000, and so on, right? But we should take care of that. Maximum number of users supported is 256 users in case of Corning, right? And what is the transmit power? So transmit power is 250 milliwatts, right? So if you remember, 1 watt is equal to 3 dBm. So can you tell me what's the value of 250 milliwatt? Can you please write in the chat box? Thanks guys for giving the right answer. So 250 milliwatts will be 24, right? And what will be 500 milliwatt? It will be half of 1 watt. Then it will be, so 500 milliwatt will be 27 dB, right? So always remember 1 watt is equal to 30 dBm, or 1000 milliwatt is equal to 30 dB. So this supports various radio modes like 310, 220, 320, 330, 340. And for 5G, they supports two kind of radios. One is RN520 and RN530. So RN 520 supports 28 gigahertz and RN 530 supports 39 gigahertz, right? So in case of 5G, their block diagram is little bit different. So instead of service node, they have a centralized unit, and centralized unit is connected to power supply, and power supply with the help of this composite cable is connected directly to the radio nodes. Only three components are required in case of 5G: radio node, power supply unit, and the centralized unit. So this is what we have seen, that we have centralized unit for 5G, then we have power supply unit, and then it's connected to radio node of 5G. And in case of LT, we require service node, and service node is connected to aggregation node, and then PoE, and then it's connected to the radio node. So first thing is the service node. So service node lies at the heart of Avron ERAN solution. It ensures that ERAN system is easy to deploy and manage, and that it delivers the performance mobile operators can expect, right? And if you want to get more details of this service node, then you can click on this link and you can see all the details of that particular service nodes, right? All those details will be here on this particular website. So they have various types of service node available, like we have 9001, it supports 50 radio nodes. Then we have 9002, it supports 125 radio nodes, and so on, right? Then we have this aggregation switch. So an aggregation switch can be used to fan out to multiple PoE plus switches, and the service node server provides IP address to the radio nodes through the aggregates, right? And the connection between service node and aggregate switch can be fiber or the copper. You can see here, it can be fiber or it can be copper. Then we have this PoE plus switches, right? So radio nodes get their DC power using this power over Ethernet on copper cable using PoE plus switches. So radio nodes get their DC power using power over Ethernet on copper cable using PoE plus switches. The maximum PoE plus cable run is 100 meters, or you can say 328 feet. And there will be always a Cat6 cable or twisted cable between PoE and the radio node. And then we have this radio node naming convention. For example, in Verizon, they are using two bands, band 4 and band 13. So how they name? So first one is SCRN. So SCRN is Avron small cell radio node. Then we have this 310. This is a model number of the radio node. Then we have this 041. So these are the last four digits in the names and represents the bands that the radio node will radiate. For example, SCRN-310-413 would be the small cell to use for this Verizon, right? Let's see the real example of Corning small cell. So you can see here, we have one service node. Service node is connected to the aggregation switch, and then it is connected to the PoE, and then PoE is connected to the radio node. And then in some cases, sometimes radio node is also connected to the antennas, right? So in this case, this radio node will act only as a radio. It will not act as an antenna, right? So radio is connected to the antennas as well. So this is what I said. So first of all, we have this service node, then we have this aggregation switch, then we have this PoE, and then we have this Cat6 cable between PoE and the RN, and then we have this RN, they are using 310, and then we have this cable between RN and the splitter, which is coaxial jumper they are using. And so the loss of coaxial jumper is fixed. So for 1000 megahertz, it will be 0.69 gigahertz. For 8000 megahertz, it will be 2.6 gigahertz, and so on, right? So it is a jumper, and it is a 9 feet jumper. And then there is a hybrid coupler also. We'll talk about hybrid coupler details in next few slides. And then it is connected to an antenna, right? So this is the high level real world example of Corning small cell, right? So again, we have SN. SN is connected to aggregation switch, and aggregation switch is connected to PoE, and PoE is connected to the RN. So this is the real world example of the Corning small cell. So our next topic will be Ericsson small cell. The details of Ericsson small cells is available online. So if you go to these websites, for example, if I go to this website, you can see all the details of radio dot system of Ericsson, right? All these things are here. And if I go to second website, you can see all the details are available for radio dot system in detail. I have taken these pictures from these two slides only. Okay, so let's talk about Ericsson small cell. So Ericsson small cell has a very simple deployment. So let's talk about the components used in the Ericsson small cell. So they have what you call, first thing is R dot. R dot is connected to something called IRU, which is indoor radio unit. And then IRU is connected to something called DU, which is digital unit. The cable between IRU and DU is the fiber, and the cable between IRU and R dot is the LAN. Okay, so this is the high level structure of R dot Ericsson. Again, as I said, it consists of three parts. First one is R dot. So R dot is an indoor optimized ultra compact radio, and it is discreet and easy to install, and it has single and dual band versions as well, and it can use for single carrier, and it can use for neutral host as well, and it can be radio and power over LAN cable. And second one is indoor radio unit, and it is power and control for radio dots, and it is frequency band independent. It can be used for FDD, TDD software defined radio, and it can be remote or co-located with baseband. And the third one is BBU, and it is RDS plus micro radio pooled baseband, backhaul and security and sync. So it has backhaul, sync and security, and then it is scalable option to meet the capacity need. Again, three parts: R dot, IRU, and the baseband. So what are the technical specifications of R dot? So they have single band dot as well as double band dot, and the size and weight is like 3.9 inches and 10 ounces, and here we have 5.5 inches and 16.8 ounces, and power is like 17 plus 17, and here we have 17 dBm per band, and both supports MIMO. And then the instantaneous bandwidth is here 40 megahertz and here 80 megahertz. And in the last class we have talked about two things. One is instantaneous bandwidth, and second one is occupied bandwidth, right? So we will not go in detail of these two terms, but you can see my last session. So IBW versus OBW, right? And then technology it supports are like WCDMA, LTE, CBRS, and 5G as well. Okay, and cable length it can support maximum 650 feet, depending on which kind of cable you are using. Are you using Cat6 cable or the fiber cable? And then we have IRU, and one IRU can support 8 radio dot units. This is very important information. So one IRU can support 8 radio dot, and one baseband can support between 3 to 24 IRU, right? So this is three components. Again, R dot, IRU, and the DU or the baseband unit, right? These three components are required for Ericsson R dot or Ericsson small. So in case of Ericsson, various kinds of R dot options are available. So if you go to this website, all those details will be there. So if I go to this website, as I said, Course Hero is one of my favorite website to get documents related to any company or any OEM. So if I go there, you can see all the dots available for Ericsson. You can see here various kinds of dots available like 2242, 2243, 53, 4442, all those dots available, and their technical data and specification available on this particular website, right? Suppose 2274, right? So 2274 supports which bands? It supports B25 and B66 bands, right? And its transmit power is around 2 cross 23 dBm. Then we have this 4475. It supports B41 band and B4 band, all these bands, right? So all these details can be available on this particular website. Let's move. So Ericsson R dot supports many kind of solutions. It can be single band R dot, it can be single band R dot, it can be dual band R dot, or it can be tri-band R dot. And they have various options available, like it can be single carrier options, it can be neutral host options as well. So they have all the options. In case of Ericsson, they can be single band R dot, dual band R dot, tri-band R dot, single carrier R dot, neutral host option. All these options are available in case of Ericsson R dot. Before going further to the R dot neutral host, I want to talk about two terms. One is MOCN and one is MORN. So they are two approaches for RAN infrastructure sharing. One is MORAN, which is multi-operator radio access network, and second one is MOCN, multi-operator core network. So what's the difference between these two techniques? So in both of these sharing techniques, the same RAN is shared by two core networks from network operator 1 and for network operator 2. So in MORAN, which is multi-operated radio access network, each network operator has its own frequency, while in MOCN, which is multi-operator core network, radio frequencies are shared between network 1 and network 2. So there are several key benefits of this sharing. Primarily, it reduces cost because by sharing a common radio network, service providers can avoid the need to build and maintain their own networks. And then we have this MORAN. So it proposed an architecture where E node Bs and G node Bs are shared, while the core network is proprietary to each network provider. So the MORAN standard also proposed the sharing of RAN, radio access network, using dedicated radio frequencies assigned to each service provider. So in this approach, they can independently control cell level. Example, each operator can decide its own optimization parameters like TX level parameters, idle mode parameters to control the cell range and the interference. But in case of multi-operator core network or MOCN, it allows the sharing of same architectural elements as MORAN, like E node Bs and G node Bs. But in MOCN, the operator also shares frequencies. So here, operators can't control their network at the cell level. So again, what are the differences between multi-operator core network and multi-operator radio access network? So here they have independent core. Base station is also shared between base station is also shared both for MORAN and MOCN, and frequency spectrum in case of MORAN is independent. So you can change the parameters related to frequencies, powers, and other kind of parameters. But here it is shared, so you can't change it. Cell coverage area is independent, and here it is also independent, right? So this is the major difference between MORAN and MOCN. In MORAN, it is independent, but in case of MOCN, frequency is shared between different RAN operators, right? Whenever we talk about neutral host options, we are talking about MORAN. So suppose we have operator A, then we have operator B, then we have this operator C, right? So all these operators BBU, right? So here we have also BBU. Operator C also have a BBU. So operator A, and then we have this IRU. So operator A BBU is connected to IRU, operator B BBU is connected to IRU, and then operator C BBU is also connected to IRU, and then it is connected to R dot. So suppose we are using 2274, right? So here B25 and B66 is shared, right? So it can be operator A, then B25, B66 operator B, then again B25, B66 operator C, right? So each operator can use the full available spectrum, and we need only one R dot. So one dot per location shared between operators, 2 bands per operator, and it can also offer 2T 2R MIMO at no additional cost, right? So this way you can use neutral host R dot as. There's a beautiful video available online on R dot, that is around 1 hour video. So if you go to YouTube and open this video, very well explained so they give very well explanation of R dot. So you can see this video if you want more explanation of R dots, right? So this video is great video related to R dot, right? And before moving to more technical discussion of R dot, I want to share one thing. Suppose we have feeder cable, right? So suppose we have cables, we have feeders, then how the cable loss or feeder loss changes according to diameter or frequencies. Suppose here we have loss in dB per 100 meter, and then we have here suppose size, right? And here maybe we have bands, right? Suppose size is ½ inch, right? And then suppose size is 7 by 8 inches, right? So size is increasing as we move downwards, and suppose our band here is 450 megahertz, then we have 700 megahertz, then we have 800 megahertz, and then we have 900 megahertz, right? So as we go from small diameter to large diameter, our loss decreases. For example, for ½ inch cable, the loss may be around 4.7, okay? But for 7 by 8 inches cable, the loss can be 2.7 dB per 100. But as we move towards higher frequency, right, then our loss increases. Like for ½ inches cable, the loss for 450 megahertz is 4.7, but it increases to 6 dB per 100 meters at 700 megahertz. And for 7 by 8 inches cable, it's 2.7 for 450 megahertz, and for 700 megahertz, it may be 3.4, right? So just remember, when the diameter increases, our cable loss decreases. But when our frequency increases, our cable loss increases. This is a very important concept that can be used in next few slides. So you should remember this. And one more thing you should remember is the American wire gauze. It is also called AWs, American wire gauge, right? So these are a standard sizes for wire conductors. Just remember, the smaller the wire gauze, the larger the diameter in inches or millimeters, and vice versa. For example, wire number 30 AWG. Here you can see the diameter is 0.30. But as we move towards 28 AWG, the diameter is 0.35. So as we move down, the numbers are decreasing, but the diameter is increasing. This is a very important concept that can be used in small cells. So you should remember the AWG concept. Okay. So as I said, in case of R dots, we have various kinds of R dots available. In addition to that, we have various kinds of IRUs also available. Some IRUs support RJ45, some support SFP plus, right, optical. But as I said earlier that the cable length, maximum cable length between IRU and between R dot can be 100 meters. But if we want to increase the distance between IRU and R dot, then what to do? In that case, we can take the help of one thing which is called RFX, right? So what we'll do, so there is one IRU and then there is a hybrid cable. Hybrid cable is connected to a unit called RFX and then it is connected to a R dot, right? And this R dot has RJ45 connect, right? And this is the hybrid cable, right? So from this IRU, there will be two ports. So one port or one cable is like a fiber cable and second one will be a DC connector cable, right? So it will be a DC connector. So in this hybrid cable, two cables will go. One will be a fiber and one will be a copper cable, right? And then here also in RFX, two ports will be there. One port will be for SFP and one port will be for DC connect, right? And then from RFX to RJ45, there will be a Cat6 cable, right? So this way you can increase the length between IRU and the R dot, right? But the length of hybrid cable is dependent on the gauze. Like for example, for 12 AWG, maximum length can be around 700 meters. For around 14 AWG, it can be around 400. For 16 AWG, it can be around 270. Just a approximate number. So it depends on various things. It depends on R dot, types of cable you are using, types of R dot you are using, IRU using, right? So just an approximate idea, it can be this amount of length for various kinds of gauzes. And there are some dots also where in addition to RJ45, SFP module is also there, right? So SFP module is also there. In that case, we do not need RFX. So just directly connect IRU with the help of hybrid fiber and it is connected to this SFP module, right? Or you can say LC connector, right? And for power, they have RJ45 power plug, right? And there is one more option available. Suppose you do not want to use hybrid cable. In that case, we have IRU, we have RFX, we have R dot, right? In that case, we can give power to RFX with the help of PoE or local power. In that case, we don't have to use this hybrid fiber. So here we can use fiber only. No need to use hybrid fiber. Just use fiber only, right? Same thing if you don't use same thing if you are not using RFX. So fiber only. And here for this particular R dot, you can use local power, right? So these are the all options available in case of Ericsson, right? So this is why I love Ericsson R dot the most, because they have given all the options to the customer. This is all about Ericsson R dot and all of these details are available on the websites I have shown to you. So please go through all those links for more information of R dot. And next, we'll move to the CommScope small cell. So we have discussed various vendors for small cell solutions. Can you please let me know the names we have just discussed for the small cells? Thanks guys for giving the right answer. You guys are really amazing and stunning. Thanks for this magnificent response. So we have discussed various kinds of vendors. So we have discussed small cell vendors related to Corning. Then we have discussed Ericsson R dot. Then we have discussed CommScope small cell. And then we have discussed Nokia small cells. And last, we have discussed the Huawei small cell as well. So these are the 5 small cells we have discussed in detail with the real world examples. Corning, Ericsson R dot, CommScope, Nokia, and Huawei, right?